Hello everyone. In this session, we will see about uh, what is the purpose of queue, and then we will implement a queue using an array. So generally, what is meant by queue? So in day-by-day life, we will stand in every queue. Okay. So for what purpose? We will provide the service on priority basis. Whoever first come, we will serve them first. Okay. Whoever come at last, we will serve them last. That's a day-to-day life. For example, if you go to any ticket counter for ticketing purpose, so whoever goes first, they will get the priority, and then they will be get served first, and then they will be gone outside very much first. So likewise, the same concept if we implement in an operating systems, job scheduling. For example, I am using Word file, I am using some other software, I am using printer, I am using music player. So now here, how the job will be get scheduled. Okay, so which one will be give more priority, which one will be give less priority? That's the one way of application of queue. The other way of application of queue, for example, in the ticket reservation systems, we are using IRCTC or many book my shows or many ticket systems are there. So now whoever goes first, they will be given priorities and then they will be given first. The other example or other application of queue is printer application. So even though if you give multiple print options, so whichever will be given print as a first, that will be get printed first. Okay, so once you give control P, control P, control P for many number of files, then it will go and store in the queue. Then it will execute one by one. It will execute one by one. That is application of queue. So queue is always all about first in, first out. So this is our basic introduction about queue. So now we will implement a queue using an array. So now as usual we know array is an mentioned size. Array will be always a limited size. So at first we will define the size of an array. So always here in the queue we have two terminologies. One is called front, another one is called rear. Front means the first end and rear means back end. Okay. So if there is no data available in the queue, then we will call them as a minus one, as like the stack. Okay. If top is equal to minus one, there is no data available in the stack. Likewise, if front is equal to minus one and rear is equal to minus one, then that means that there is no data available in the queue. So for example, here we have defined n and n as a 5. We have defined n as a 5. So the array data going to be 5 number of data can be stored in a queue. So queue is an queue of n. Okay, which means that we have declared an queue in an array. Okay, and then we have declared front is equal to minus 1, rear is equal to minus 1. So as usual, we will see different operations over here. The insertion or deletion. Whereas in the stack, we will call push or pop. Push means insertion and pop means deletion. Likewise, in queue, we will call them as a enqueue for insertion and dequeue for deletion. Okay, so at first we'll go for enqueue. So enqueue means what? We are going to insert a data. We are going to insert a data. So when we are going to insert a data, we will get a data through one variable called x. So I have given void enqueue and then I have given integer x. So through x variable, we are going to get a data from the user and then we are going to add it up in the queue. So then at first I will check whether the queue is full or not. So how do we know that queue is full or not? So for example, so this is a queue. We have an 5. So 1, 2, 3, 4, 5. So the array index is going to be 0 and 1 and 2 and 3 and 4. So here I will store the data. I will store the data. So now what happens over here? Some data are there. 7, 8, some 3, 2, 9. So these are data. So front will be equal to 0 because index, this is the index. Front value will be equal to 0 and rear value will be equal to 4. If both are minus 1, that means that there is no data available. When there is no data available, then it's going to be minus 1. Front always indicates the first data in the queue, and rear always indicates the last data in the queue. So the front and rear. So if front is equal to -1 and rear is equal to -1, no data. If front is equal to 0, then there is a first data available. And if rear is equal to n-1, what is the n value over here? We have declared as a 5. So if rear is equal to 4, that means that the queue is already full. The queue is already full. So when we do the enqueue operation, the first step we will go for whether the queue is full or not. Because if the queue is full, then there is no meaning of inserting data over there. So we will check for an if rear is equal to n-1, then I will print it as a n-1. If print is, I'll print it as a overflow. I'll print it as a overflow. So if rear is equal to n-1, then what do? I will print as a overflow. Else, so the other case is going to be front is equal to -1 and rear is equal to -1. So that time there is no data available in the queue. Then what do? I will assign the index value for both front and rear as a 0. If I have only one data, then front and rear both will be front also 0 and rear also 0, because I'm having only one data available over here. So if I have only one data, that's a first data, that's a last data. So front is 0 and rear also 0. So the second case is going to be else case. Else if front is equal to -1 and rear is equal to -1. So now what I'm going to do here, else if front is equal to -1, rear is equal to -1, then front and rear will be assigned to 0, and then I will store the queue of rear. So what's the queue of rear? Queue of 0. In the queue of 0, in the queue of index 0th position, I have stored the data called x. Then suppose now I have one data available over there. The last case is going to be if I going to store a second data, then just I can increment a rear by one position, and then I can allocate a data over into the second position. Simple as that. So else the rear will be gets incremented. The rear will be gets incremented. Now rear is 0 in the previous case. Now rear will be increments to 1. So in the queue of 1, I will store the value new data. So in the queue of 1, I will store the new data. So before storing the new data, the rear will be gets increments to 1. So 0 becomes 1 over here, and new data has been added over in the queue. So then if I want to insert a third data, then what we will do? The rear will be increments to 2, and then I'll store the new data. Then if I add one more data, the rear will be increments to 3. I will add one more data. Then if I want to add one more data, then rear becomes 4. Then I'll add and one more data. So this time it will check for rear is n-1. So the queue is full. It will not add a new data over it. This is operation called an enqueue. This is operation called enqueue, the insertion of data in the queue. Now we will see an operation called dequeue. So what is a dequeue over here? Dequeue is nothing but deletion of data in the queue. So the deletion of data in the queue is simple. If there is no data available in the queue, we cannot delete any data. So if front is equal to -1 and rear is equal to -1, there is no data available in the queue. So it is called underflow. This is called underflow. That's the first case. That's going to be the first case if both front is equal to -1 and rear is equal to -1, then there is no data available in the queue, so we will print it as a underflow. So then the other scenario might be this is a scenario. So there might be only one data available in the queue where both front and rear are 0. If there is only one data, that's the first data, that's the last data, same data. So that time front is 0 and rear also going to be 0. So if front and rear are going to be 0, then what do? I will print the queue of first the deletion data, and then I will decrement the front and rear value to the -1. So I will decrement to the -1. That's a case. So you can see here. So what will I do? If front is equal to rear. So in our case, front is 0 and rear also 0 because we are having only one data. So that time what happens over here? We will print this data which we are going to delete, and then we will decrement the front and rear value to the -1. The other case is, suppose I can have rear is 2. So the other case going to be the front might be different with rear. Okay, that time what I will do? I will decrement the data. So now if I want to delete the data, means where can I delete the data? I can delete that index only at the first in first out, right? So this is the data can be deleted over here. Okay, so the insertion can happen at the back end and deletion can happen at the front end. So if I delete this data, then what happens over here? There is no data available in the 0 index. The starting data going to be index 1. So front will be increments to 1. So if I want to delete one more data over here, then the 5 will be gets deleted and front will be increments to the 2. So now in this case, front and rear both are same. So that time after deletion of this data, front equal to rear is equal to -1 then. So that's a case, else case. In else case, whatever data available over there, I will print it up and then I will increments the front by 1. I will increments the front by 1 position. Simple, if front is -1, rear is -1, no data. If there is only one data available over there, then front and rear becomes -1. If there are many data are available over there, then we will delete the data at the front end. So then we are keep on incrementing the front by 1 position. This is the operation called Dequeue, deletion of data in a queue. The next operation going to be peek. What's a peek? It will show the first data available in the queue. So if there is front is -1, rear is -1, it's an empty. Otherwise, it will print the first data available in the queue. So peek, if front is -1, rear is -1, it is empty. Else, it will print the first data queue of front. So here the only one data available over here. So queue of front is 2, so index is 2. In the queue of 2, what data we are having? We are having data called 4. That will be gets printed. That is called peek. And then for displaying the data, what we can do? We should start from front onwards. Then we'll be keep on goes until rear. So once again here, if the first checking point will be if both front is -1, rear is -1, there is no data. So I have a local variable called I for the for loop purpose. And then if front is -1, rear is -1, then it's an underflow. It is an underflow. Else for I is equal to front. So I is equal to 0. And then I less than equal to rear. Until I less than equal to rear, it will keep on going. Okay, so I plus plus. So it will print the first data and then increments I. Increments I 1 by 1 until is equal to the rear. This is the operation of display. So through this, through this video, we have seen the operation of implementation of queue using an array. At first, we have seen the operation called enqueue, insertion, and then dequeue, deletion, and peek, and display of data in the queue. So this is how you can implement any number of any queue using an array. Thank you.